Right now, look around you. You are probably surrounded by glass, a window, a light bulb, maybe the screen you're watching this on. Glass feels ordinary, almost invisible, but its story is anything but ordinary. Thousands of years ago, humans had never seen anything like it. Nature had already been making glass for millions of years. Volcanoes created obsidian. Lightning could fuse sand into glassy tubes called fulgurites. Meteorite impacts could melt enormous amounts of rock. But humans had a different question. Could we make glass ourselves? The answer eventually changed civilization. But it didn't begin with smartphones. It began with ancient furnaces, and perhaps with a mistake. Let's go back more than 4,000 years to the ancient Near East. There, craftspeople were already working with materials that behaved strangely when heated. One of them was faience. It looked like stone, but it was made from powdered quartz, alkaline salts, lime, and other ingredients. When fired, a shiny glass-like surface formed on the object. The process was complicated, but it taught ancient craftsmen something important. Heat could transform ordinary minerals into something bright and glassy. And then, someone pushed the idea further. Instead of making only a shiny coating, they began producing actual glass. Archaeologists have found some of the earliest glass fragments in Mesopotamia and Egypt dating to around the 2nd millennium BC. The exact moment of discovery is still unknown, and that's important. There is no ancient inventor we can point to, no surviving record saying, "I invented glass." Scientists think early glassmaking may have developed from experiments with faience, or even from high-temperature metalworking. In other words, glass may have appeared as an unexpected byproduct. Someone heated the right materials. The furnace became hot enough. The ingredients reacted, and suddenly, a strange, shiny material appeared. But making glass wasn't easy. The main ingredient was silica, usually supplied by quartz-rich sand. Then came an alkali, such as soda. And another ingredient was needed to make the final material more stable, lime. These ingredients had to be heated together at very high temperatures. The result was something completely new. Not stone, not metal, not crystal. Glass, early glass, was not perfect. It contained bubbles, it could be deeply colored, and controlling its shape was difficult. But ancient craftspeople kept experimenting. They learned how different minerals changed the color. They learned how heat changed the material. They learned how to shape it. And eventually, they discovered that glass could become more than a strange lump from a furnace. It could become jewelry, a bead, a decorative object, and eventually a vessel. That was the moment glass began its transformation from an accidental material into one of humanity's most important technologies. For centuries, glass remained rare. It was not something ordinary people used every day. It was precious, almost like a gemstone. Ancient craftspeople first learned to shape small pieces, beads, amulets, decorations, but then they faced a much bigger challenge. How do you turn a lump of hot glass into a container? The answer was an ingenious technique, core forming. The method appeared during the 2nd millennium BC in Egypt and Mesopotamia. A craftsman first made a small core, usually from clay and other materials. The core was attached to a rod. Then came the dangerous part. Molten glass was wrapped around it. Layer by layer, the hot glass covered the core. The craftsman could then add colored glass, draw patterns across the surface, and smooth everything with simple tools. After the vessel cooled, the core was removed. What remained was a small, hollow bottle. These vessels were often used for valuable liquids, perfumes, oils, cosmetics, and medicines. They were beautiful, but they were slow to make. Every vessel required skilled hands. One mistake, and hours of work could be ruined. Still, ancient glassmakers kept experimenting. They discovered that tiny amounts of different minerals could change the color. Copper could create blue and green shades. Iron could produce darker tones. Other ingredients created yellow, white, or red effects. Glass became a kind of ancient chemistry laboratory, and the technology kept improving. By around 1500 BC, Egypt had become an important center of glass production. But glass was still mainly a luxury. A small glass bottle could represent enormous skill and wealth. Then, something happened that would completely change the future of glass. Someone discovered a way to shape molten glass much faster. No complicated core, no hours of careful winding. Instead, a hollow tube, a blob of glowing glass, and one simple breath, glass blowing, was born. And suddenly, a material once reserved for the wealthy was about to become something ordinary people could actually own. Then, around the 1st century BC, a breakthrough appeared in the Eastern Mediterranean. Glassmakers discovered something astonishing. They could blow molten glass into shape. The basic idea was simple, but the effect was enormous. A craftsman gathered hot glass onto the end of a hollow tube. Then he blew air through the tube. The glass expanded. A glowing bubble appeared. With tools and careful movements, that bubble could become a bottle, a cup, a bowl, or almost any hollow shape. Before this, making a glass container was slow. Core forming required many careful steps. The new technique was much faster, and that changed the economics of glass. Glassmakers could produce many more vessels. The technology spread quickly, especially through the Roman world. Soon, glass was no longer limited to tiny luxury bottles. It became useful for ordinary life, storage jars, drinking cups, small containers, decorative objects, and eventually, windows. Roman glassmakers even produced large sheets of window glass. It was not perfectly clear like modern glass, but it had one huge advantage. It allowed sunlight into buildings while keeping much of the wind and weather outside. A simple idea, but a revolutionary one. Glass had started as a rare luxury. Now, it was becoming part of everyday life, and the Romans pushed the material even further. They experimented with colors, shapes, patterns, and incredibly complicated designs. Some vessels were so advanced, they still amaze researchers today. But glass had another secret. It could bend light. And once humans learned how to control that, glass stopped being just a material for containers. It became a tool for seeing, and that would change science forever. A small piece of curved glass could make distant objects appear closer. Another could make tiny objects appear enormous. For the first time, humans could look beyond the limits of their own eyes. The next revolution would not happen in a furnace. It would happen in front of the eye, and it would reveal a world nobody had ever seen before. Glass was no longer just something to drink from. It was becoming a way to see. The first big step was eyeglasses. By the late 13th century, Italian craftsmen were making spectacles. They used curved glass lenses to help people see more clearly. That may sound ordinary today, but imagine the impact. A person who struggled to read could read again. A scholar losing his close vision could continue studying. Glass had become a tool for extending human sight. Then came an even bigger idea. What if one lens could work with another? What if glass could make distant objects appear closer, or tiny objects appear much larger? That idea helped create the optical instruments of the scientific revolution. In the early 1600s, the telescope appeared, and scientists quickly realized what it could do. Point it toward the sky, and the universe suddenly looked different. Mountains appeared on the moon. Stars became visible that the naked eye could never see, and distant planets became objects that humans could study. Glass had become a doorway into space. But there was another direction to look, down toward things far too small for the human eye. The microscope emerged around the same period. Early microscopes were crude, their lenses were imperfect, their images were often blurry, but they opened a completely new world. Scientists could examine tiny structures, cells, fibers, and eventually microorganisms. Antony van Leeuwenhoek pushed this idea further than almost anyone. He was not a university professor. He was a Dutch tradesman, yet he learned to make extremely small, powerful lenses. Through them, he observed a hidden world of tiny living organisms. His discoveries helped transform biology and microscopy. Think about what had happened. Ancient humans had first encountered glass as a strange material. Thousands of years later, humans were using it to explore places they could never reach with their bodies. The telescope opened the enormous world above us. The microscope opened the invisible world below us. And glass had one more trick. It could also control light itself. Scientists began experimenting with prisms, optical instruments, laboratory equipment, and precision glassware. Glass became essential to scientific experiments and measurement. But this was only the beginning, because humans were about to discover something even more powerful. Glass didn't have to be thick. It didn't have to be a bottle. It could be made into an incredibly thin strand. and through that strand, light could carry information. The material that began in an ancient furnace was about to become the backbone of the modern world. But glass had one final transformation. It was about to become almost impossibly thin enough to carry light, and that light could carry information. The idea appeared in the 20th century. Scientists realized that extremely pure glass could guide light over long distances. But there was a problem. Early glass fibers lost too much light. The signal would disappear after traveling only a short distance. Then, researchers found the real problem. Impurities. Tiny amounts of unwanted material were absorbing the light. So, they tried something difficult. Make the glass incredibly pure. In 1970, researchers at Corning developed an optical fiber with dramatically lower signal loss. That breakthrough helped make practical fiber optic communication possible. Suddenly, glass wasn't just helping humans see, it was helping humans communicate. Light could travel through a glass fiber, carrying information across enormous distances, under oceans, across continents, between cities. The internet may feel invisible, but much of its physical infrastructure is not. It is glass, tiny strands of engineered glass carrying pulses of light. And the story didn't stop there. Glass also became stronger, much stronger. Scientists developed special treatments that could strengthen its surface. That technology eventually helped create tough glass for modern electronics. Phones, tablets, displays, the glass in your pocket is not the same material ancient craftspeople made thousands of years ago. But the basic idea is still familiar. Take ordinary raw materials, apply heat, control the chemistry, and create something with properties nature rarely gives us. That is what makes glass so remarkable. It can be transparent. It can be flexible at extreme temperatures. It can carry light. It can protect us. It can magnify the smallest things. And it can reveal objects billions of kilometers away. Think about where this journey began. Ancient people working beside a furnace, experimenting with sand, minerals, heat, perhaps noticing a strange shiny material forming where they didn't expect it. They couldn't have imagined telescopes, microscopes, optical fibers, or smartphone screens. Yet their discovery became the foundation for all of them. Today, the Corning Museum of Glass preserves more than 50,000 objects, representing thousands of years of glass history. That history tells us something powerful. The most important inventions don't always begin with a grand plan. Sometimes, someone notices something unusual. They ask a question, they experiment, they fail, they try again, and eventually, a simple material changes the world. Glass began as something ancient humans barely understood. Today, it helps us see the smallest structures in nature. It helps us study the universe. It lets sunlight enter our homes. It protects the devices in our hands, and it carries our messages beneath the oceans. From an ancient furnace to the screen in front of you, thousands of years later, we are still finding new ways to use the same remarkable material. Glass didn't just change what humans could see, it changed what humans could know.